Okay, so this question is about something that we haven't covered yet. However, I'd like to show you that sometimes, by having some polite guesses, you can actually get to some quite good results, and you can solve some questions even if you don't quite remember how to solve them, or the equations, or, So especially when you're working with graphs, usually you can get something either with the area or your tangent, so your gradient line. So in this case, the graph shows the variation with time of the resultant net force acting on an object. The object has a mass of 1 kilogram and is initially at rest. So initial velocity is 0. Okay? If initial velocity is 0, well, let's see, it's going to suffer some force, so it will start moving, there will be an acceleration and such. But if we take a look at this graph, it's a force-time graph. And what is the velocity of the object? So we're being asked, what is the velocity? Let's think about this. I've got force and time. So what if I calculated the area? Just because. Let's think about this. What would I have? What unit would this be in? So if I multiply something, I'm not going to calculate the area properly here. I'm just looking for the units, okay? Then we will do some maths. But for now, if I multiply here force and time, what would this give me? Well, force can be expressed as mass times acceleration. And acceleration multiplied by time, that's a velocity. So if we multiply a force and a time, we would have something in the unit of mass, right? So kilograms times velocity, meters per second. So if we're looking for the velocity of this object, we could basically calculate the area of this shape, which will give us some mass times velocity, and we can divide by the mass. So if we do that, what would be the area of this graph? Well, it's a triangle, it's a right triangle, so we can just multiply 200 times 80 divided by 2. However, this time is in milliseconds, so I have to multiply this by 10 to the power of negative 3, so I keep everything consistent in our SI units. So if I multiply those, this 10 to the power of negative 3, I can get rid of this 0 and this 0 and this 0, and also I can get rid of this 2. So this is 8. And the unit, as we have found out, would be kilograms meters per second. So if I multiply this area by the mass, I would get something in the unit of meters per second. However, since the mass is 1 kilogram, this would be 8 kilograms meters per second divided by 1 kilogram. So we just get rid of the units. So this would be 8 meters per second. Letter A.